Okay, so let's dive into the lecture. I usually like to walk around, but because the camera doesn't move with me, I'm just going to kind of stay rooted right here. So it might look kind of awkward with me. I'll try to walk, but then I'll come back. So what is sports science? This is a critical topic because I think 5 to 10 years ago, nobody really knew what sports science was. Now people think they know what sports science is, but it's really not what they think it is, right? People think, well, I should really have come up with one of those memes with all those pictures, you know, like what my mom thinks sports science is and what it actually is. But we're going to answer that question. So today's agenda, the first thing, we're going to define some terms, okay? Then we're going to talk about what sport versus exercise science is and the critical difference between those two disciplines. There's a lot of overlap for sure, and a lot of people glide seamlessly and effortlessly between the two, but to do so, you have to understand the difference in the research paradigms and the goal of each of those disciplines. Then we'll talk about some early training theory and move our way into current and modern training. We're not going to do a huge deep dive into periodization, but just to give you a little bit of a foundation to the fact that really nothing is new under the sun, right? We think, oh, periodization and microcycles, and they had that thousands of years ago, and we're going to look at some of that. We're going to talk about the art versus the science of coaching and a black box versus a white box approach to training, and then get into evidence-based practice and what does that look like and how can we use sports science to drive evidence-based practice in our training, okay? So first, what is sports science? And to define that, we have to start, I like to break it down into each component word. So first, what is sport? We think we know what that is, but oh, sorry. Not what is, I have those out of order. That should say, what is science in bold? So what is science? Science is a search for truth. It's not an opinion. It's not something that you think or a philosophical debate. It's a search for truth using empirical observations. We're trying to establish facts of what is, not what should be, not what you think it should be. The basic tenet is that truth is out there and it can be measured, okay? It can be measured. So when we're thinking of an athlete in the weight room and we're looking at their bar speed, we might think it looks fast. But the truth is that there's a certain velocity of that bar and we can measure that velocity. And then we can use that as an objective outcome to feed into their training right then and to compare them to other standards, whether it's against the athletes on the team or against a set of norms or their previous history. So we strive to be objective and quantitative as much as possible. There is definitely a place for qualitative data and for what we call the coach's eye and for just sort of that human sense of things and person-to-person interaction. Those are all very important. But you could think of that as like the bedside manner of a physician versus the medical training of that physician. They need both. And how many of you have been to a doctor with a really poor bedside manner and you just leave feeling like crap and you're like, you know, I don't want to go back to that person. Same thing with a strength coach. The qualitative relational aspect is huge, but it's only 50% of the game, right? We also have to quantify and be objective about what we're observing. Okay, so that was science. So what about sport? Well, sport is very important. If you turn on the news or go to any news website, you're going to see 3 categories. The actual news, what the weather is, and sports. Okay, so it's arguably one of the 3 most important things in life is sport. Now, the pinnacle of sport, well, maybe not for some Americans, there's other pinnacles, maybe the Super Bowl for us Americans. But the pinnacle of sport in the world is the Olympic Games. And it has been for now over 100 years since it's been reestablished. And before that, for millennia, right? Back in the ancient Olympic Games in Greece. And this is where some of the earliest training theory comes from that we have written down. And we actually don't have records of the actual training programs, but we have records of historians writing about those training programs that were lost, you know, to time. So what is sport then? Sport is a competitive activity which requires that there be winners and losers. Okay, maybe not at the Pee Wee level, maybe not at the everyone gets a trophy level, but eventually in sport there has to be winners and losers for it to be called sport. A couch to 5K program where you go do a turkey trot, that's not sport. That's recreation. That's something fun to do. That's something good for your health. That's not sport. In fact, in sport, you're not even there for your health, okay? The thing that a lot of people don't understand is that at some point, at some level of competitiveness, fitness for your sport and health become uncoupled, right? Does this make sense? Sam could probably attest to this in football, right? Yeah. How much does the average O lineman weigh?
305, over 300 pounds.
Over 300 pounds. Is that good for your health?
No.
No. But if that offensive lineman was to shed down to, let's say, 250 or maybe even 220, get super lean, would they be effective in their position? No, they would not be fit for their sport. So we have to start to think of fitness not as health. That's how most people think of fitness. They'll say, oh, he or she is fit. And that usually just means that you can see their abs, right? For us, fitness means, can they accomplish the demands of the sport effectively? And not only effectively, but better than the other team, okay? Better than the competitors that they're competing against. Now, so we've defined sports science. We've talked about what is science, what is sport. Now, what is sports science compared to exercise science? Because we have to combine those terms because they mean something different. It's not just the sum of both words. It means something more when you put them together. So I think a lot of us are familiar with exercise science because a lot of us in our undergrad studied in an exercise science program. Exercise science uses exercise and training to further understand biology, and more specifically, physiology. Okay, so they're using training interventions, and then they want to know what happens to the human body because of that training, or during that training, or after a longitudinal training program. What are the adaptations? Now, their primary goal is to make discoveries or to make observations that apply to the general population. Okay? Not necessarily to elite athletes. But for sports scientists, we want to use biology, and really we want to leverage all of the scientific disciplines, not just biology, but mechanics and physics is in there, nutrition, exercise physiology. We want to leverage all of the sciences in order to drive sport performance. Does this make sense? So it's just sort of flipping the paradigm on its head. It's an inverse. Exercise scientists use exercise to study biology. We use biology and science to drive sport performance, not always even to study it. Yes, we study it, but as a sports scientist, if you're an applied sports scientist, performance is first. Research, publications, scientific inquiry is second. It's a byproduct of good performance and being a good, careful scientist with good observations and attention to detail, recording, keeping track of your data, et cetera, et cetera. So here's how this looks. We have basic science at the top. Okay, so chemistry, biology, physics, the basic sciences. From there, as two different and unique subcomponents, but that both have overlap, we have exercise science and we have sports science. Now, both of them have research components and both of them have education components. Right now, you guys are in the education component of a sports science program. And if some of your colleagues from the exercise science program were sitting in here, which I thought some of them were signed up for this class, but I guess not. I guess they bailed. They would be in the exercise science education part. There's also both research components, but the difference here is the service aspect. Each of these different disciplines has a distinct service aspect. For exercise science, it's more about wellness and then also about strength and conditioning. Okay, because there's a huge overlap for that. The general population really needs strength and conditioning a lot, and again, we can apply that to the general population. For sports science, it's monitoring and testing, and also strength and conditioning. Okay? Okay, we're gonna move on to early training theory. And remember, the reason we're going over this, there's actually some really cool presentations sometimes at the NSCA conferences on the history of strength and conditioning. Just fascinating stuff, and more into like the last century. But I want you to know this because I think sometimes we can have, and I'm forgetting which fallacy it is. I think it's like the chronological fallacy, snobbery, I think is the term. Chronological snobbery, where we automatically think that the most recent thought processes or concepts or paradigms are better than the older ones. But in reality, a lot of this stuff has been around for quite a long time. They just didn't necessarily have the technology to quantify things to the same extent that we do, nor did they have the human sort of technology of the scientific process in order to test their theories. But let's go way back to one of the Greek legends and I think 5 or 6 time Olympic champion wrestler, Milo of Croton. You guys know this story, Milo of Croton? He gets massively strong by carrying a bull up a mountain every day and then back down. But he doesn't start here. He starts when the bull is a young calf, okay? When it's light. And every day as a calf increases in size, he does it again and again and again, which is getting at the principle of overload. And this is how the ancient Greeks explained his massive strength. They explained it through this principle of overload. They sort of worked backwards. Instead of saying, hey, Milo, here's the principle of overload, which comes down from our sports scientists and Nike, the god of victory, you should train this way. Instead, they worked backwards and they came up with this principle of overload, that he must have done something like this to get as strong as he is. Now, the story actually ends quite sadly because he does this every day, and then when the bull is full grown, he actually slaughters the bull and kills it and eats it all in the same day, which is part of the legend. So that's kind of sad. I would have thought they would become friends, you know. You got to get the gains, yeah? There's a lot of protein in that bowl. Yeah, he actually did eat raw meat in front of his competitors in order to intimidate them, and then he would drink the blood of a bull.
So is that where the carnivore diet started?
That might be the foundations of the carnivore diet. Yeah, the liver king. Yeah, that dude is liver king. Yeah, I'm gonna edit that out of my video.
No, it's just liver.
The next is the Roman gladiators, right? And we have this image of gladiators as these like kind of this barbaric sort of ritual where they just kill each other. But actually it was almost like a highly stylized and even a refereed sport. Yes, there was a lot of injury. Yes, there was a lot of death. But not just slaves competed as gladiators. There were also even noblemen who competed. There were professional fighters who competed as gladiators. It was like the present day MMA if there were also weapons and bigger coliseums and animals that you could fight. Okay, so the Roman gladiators actually came up with the earliest form of the microcycle and early periodization. And again, the actual training programs don't exist anymore, but we have historians who have written about it, and it was called the tetrad system, developed in ancient Greece. And it's a 4-day microcycle. Right? We typically operate on a 7-day microcycle, or maybe a 10-day microcycle if you're weird, or sometimes up to 2 weeks if you really want to spread things out. But they operated on 4 days. And really, this is kind of like a high-low or a heavy-light or almost an undulating type of approach. On day 1 was what they called preparation. This was more toning and calisthenics, short, fast, rapid movements, not very fatiguing. It's some type of interval training where they would move very quickly and vigorously, but then rest, and then do it again, on and off. Day 2 was their high intensity day. And when I say high intensity, don't think CrossFit and interval training, because that was more on day 1. It's not high intensity intervals, but it's high absolute intensities. These were where they did feats of strength, and they tested themselves through max efforts. On day 3, this was the restorative day. Okay, so they had a medium day, they had a heavy day, and then they had a restorative day where it was just light movement to get the blood flowing. It was nothing too heavy, mostly focused on recovery. And then finally, on the 4th day, it was more sport specific. This was a moderate effort day where they worked on specific grappling techniques or gymnastics techniques, things that applied directly to their sport after they were recovered. After this, then they would rinse and repeat on this 4-day microcycle. So pretty incredible, right, that they were training using some sort of a logically sequenced, heavy light day approach where the SRA curves, the stimulus recovery adaptation curves, were, they're more or less accounting for that. They're not doing sport-specific skill work when they're really fatigued after the super heavy days. They're not doing 2 really heavy days back to back because they know they need recovery, okay? Now, what they didn't have back then, they didn't have any type of objective monitoring system to tell them whether or not this is actually working for them or how they could possibly tweak this over the long term. Yes, they did keep good records and could look back on them, but they had no way of objectively determining, well, what was the velocity of that athlete? They had no way of timing him unless he raced somebody else. It's just who won, not how fast did you do it. I guess they could have those sand timer things, right, and standardize it that way, but I don't know. That would be pretty tough. Imagine your coach just being like, go, and the sand's just running out. You have 4 grains left. Yeah. So cue athlete monitoring. Okay, this is what we use now in the modern era to refine our training processes and tweak it for individual athletes and for programs as a whole. Okay, athlete monitoring. But what is athlete monitoring? It's a component of sports science, and I mentioned earlier that monitoring is different than testing, although we use a lot of the same tests in both of them. Okay, so we'll talk about some of the differences here. Before we understand why we need monitoring, we have to talk about the role of a coach, okay? And the role of most coaches is, I put myself down there because I wanted to be on the slide. But the other two are Point Loma coaches. I'll just read this to you. A coach's worth. In most university athletic departments, a coach's worth is typically assessed by their win-loss record, or in some sports, such as track and field, by their ability to improve the competitive rank of athletes under their supervision. So in track, you don't have to win everything, but you can move up in the national rankings because it's the most objective of sports. But this is essentially what we call a black box procedure. A black box procedure is where you don't know what's going on inside the box. And if we think of training as a box and the win-loss record as the ultimate judgment of how good or bad a coach is, then really we have no idea what's affecting that win-loss record and what's affecting our evaluation of the coach. And here's what it looks like. We have an input, which is the previous win-loss record. We know what they did last season, okay? And we have athletic preparation, which is driven by the coach, and we expect the coach, we pay that coach to prepare the athletes. And we say, coach, you're a coach. You should, be the expert in this. Prepare your athletes in order to improve their win-loss record. And then we see the results. This is how, for a long time, most of sport worked. And it's still how it works, in the absence of any type of monitoring or data collection, okay? And I think you guys can see the problems with that, yeah. Yeah, you can't exactly look back on last semester or last year or last season and have any objective changes or tweaks. Sure, the coaches probably keep records of things, and the best of them do, and they keep meticulous records, but you can't translate that to other people, or other people can't look in. You can't have other stakeholders or other people as part of the support staff speak into that if you're not objectifying all of your data. So so then, in order to counteract this, we have to take an evidence-based approach. So the evidence-based approach in sport training has 3 primary aspects. The first is an ability to find and read and critically analyze scientific and coaching literature. Okay? Coaches need to be educated. They might not go and read the primary articles that are coming through in the scientific journals, and that's totally fine. But should they at least be reading coaching textbooks or the coaches magazines or the coaching publications? Yes. Should they at least know some semblance of basic physiology and the human response to training? Yeah, probably. That would be a good idea. So that's the first part of an evidence-based practice. And even better yet, what if the coach was partnering with a researcher or a sports scientist, somebody in your shoes who has been trained to understand the literature, who can comb through it, say, hey, coach, there's this, here are some really good evidence-based, scientific, rooted in scientific principles, training practices. Let's look at how we can start adapting some of these into the training program. And let's see which of the ones we're already hitting as well. Number 2 is the development and initiation of a sound monitoring program. Okay, feedback from the monitoring program will provide evidence of program efficacy. Is your training doing what you think it's doing? Are those heavy back squats the day before the game really making you stronger for the game? Or does the monitoring data say otherwise? right? Does that period of hypertrophy training right before the season start actually make the athletes stronger? Or does it just depress all of their neuromuscular indices of readiness, okay? Should we maybe pull that hypertrophy phase back and put a strength phase in between there, a strength power phase before the season, right? A monitoring program can tell you all of these things. Is one of your athletes perhaps under too heavy of a workload, and are they no longer adapting to the program even though everybody else is? A monitoring program can reveal that to you. And third is an ability to initiate and complete additional research when necessary, but research should really have air quotes around it because not all research needs to be published from a sports science point of view. If you are a coach or a sports scientist who's taking notes, looking back at trends, doing some rudimentary statistics, and making decisions based off of that, you're doing research. You're doing in-house research that will drive the performance or the training and then the performance of your athletes. So here's what it looks like currently at Point Loma. This is our athlete monitoring conceptual model. This was adapted from Dr. Stone's work. So we have training, we have monitoring, and we have research. Notice that everything is labeled and everything is accounted for. Okay, this is an idealistic goal. We're not quite here yet, but we've made really big strides toward here from the black box approach previously. We have in green the athlete, of course, this is all centered around the athlete. It's an athlete-centric model. We have all of the inputs, not only the training stimulus, which comes from the sport coach, but also outside stressors, which we have to account for, as well as other training stimuli from the strength and conditioning coaches. Okay, those are the training inputs. Now the outputs, we break them down into some different categories. Performance assessments, training volume, mood status, fatigue status, and health status. All of these can be measured, whether it's through a test or a questionnaire, sometimes through qualitative data, but they can all be measured so that we know what is the actual effect of these training stimuli and the outside stressors. That's where the sports science staff comes in. We collect the data, we run the test, we collect the data, and we analyze it and interpret it. That's why these arrows feed back to the strength and conditioning coach and to the sport coach. So to use Yaz as an example, as a GA, Eric is training you guys to do things like daily jumps for readiness, right? And that's one of the monitoring techniques. That would be, do you know which one of these that is under? It does depend. I would say probably fatigue status or performance assessment if you're doing daily vertical jumps on a force plate. Because what if the athlete doesn't jump as high suddenly? Or maybe they jump as high, but they use a different jumping strategy. Or maybe their jump is 1 standard deviation higher than normal, than their average, right? That gives us an indication of how fatigued they are or how prepared they are. It also gives us an indication of if their performance has gone up, okay? And it takes trained sports scientists to do so. Now, the last column, this research column, as a sports scientist, your main goal is to drive training and improve performance. But as a scientist, you also need to publish. And this is where the research and education component comes in. You guys all doing your master's program, thesis, capstone projects, getting research experience under your belt, that all happens here, right? But notice that you can't have one without the other. You have to have both. And what's up, guys? Now I'm in my office because my camera cut out, but I'm going to carry on with the lecture right where we left off. So the evidence-based coach and applied sports scientist. These are two different roles that overlap, but they can also be the same person with duties on both in both spectrums. Okay, so we have the typical strength and conditioning coach, which this, if you think of like the person walking the floor, cueing the lifts, designing the programs, teaching people how to squat and press and pull, doing the periodization, working with the sport coach to align the strength and conditioning with the sport program. That's the strength coach. Then we think of the sport scientist. This is the person who is quantifying training, who is calculating training load, who is putting little wearable devices on the athletes and on the bars to get bar speed, who is integrating the latest evidence into the training programs. That's the sports scientist. Now, in today's world, both the coach and the sports scientist have a lot to learn from each other. And this is because oftentimes the sports scientist has evolved out of the role of the strength and conditioning coach. You have strength coaches who are very smart, very analytical, and they're thinking, how can I continue to improve what I'm doing here in the weight room with these athletes? And they've turned to new technology, new statistical methods, or some of them old statistical methods that are new to the strength world, in order to run data analyses on the sets and the reps and the volume load and the training loads, and to essentially fine-tune the training of their athletes so that they can achieve peak preparedness with lower levels of fatigue, so that they can target certain fitness characteristics in a more evidence-based way, in a more nuanced way. And then at the same time, you have sports scientists who, for all intents and purposes, these are like the data nerds and the technology geeks who, they might not be able to translate what they know very well to sport and to athletics, except for that they also have a penchant for coaching, and for maybe they were athletes themselves. So essentially we see like these two ends of the spectrum where there's a lot of crossover. The coach can adopt these evidence-based sort of sports science practices and tools, and the sports scientist has to be able to speak the language of the coach and have a good coach's voice and a good presence in the weight room or on the field. And oftentimes, you can play a dual role as a sport performance professional. If you have a good coaching presence and you have the sports science tools and abilities and experience, you can do both. Up until about 5 or 10 years ago, both of these roles were often accomplished by the same person. There was not enough money in the budget, nor was there recognition of the need for a separation and for specialization in each of these categories. Now we're realizing, and most organizations are realizing, hey, we need to enable the coach to do their job with the tools of the sports scientist to allow them to take a more data-driven approach to their coaching, but let them focus on coaching. And at the same time, in order to accomplish all of the roles that a sports scientist needs to accomplish, they can't also be spending 10 hours a day on the floor with the athletes and still be expected to get those data reports back to the head coach. There is a need for both of these roles in sport, but it's important for young professionals in sports science and in sport performance to realize that there's a lot of overlap. Now, ideally, it works best when both of these people, the strength coach and the sports scientist, can speak the same language, and that's why it's so important to have overlap in these skill sets. The strength coach should know how to run the force plates and know which tests are most important to run and how to interpret the results. The sports scientist should be able to walk around the floor and give cues during the tests and know what a good vertical jump looks like, and understand good squat technique and understand the programming and periodization schemes that the strength coach is using. So now we've taken this black box approach and we've made it transparent, or more of a white box approach, where we know all of the inputs that are going into the training plan. We have outside stressors, which are quantified through things like mood questionnaires. We have training load, which we can quantify with either session RPE or GPS data. We have the training methods that the coach has been detailing all along and that we can look back on longitudinally and see the history of these athletes' training. We have the previous win-loss record, which of course has always been publicly available, but that is added in there as well. The mental status of the athletes, exercise selection, performance indicators like our jump testing or isometric testing or sprint testing, and then talent assessment through various sport-specific testing measures. And all of this leads to us knowing exactly what is inside of the box. So we've gone from this black box approach and now to this white box transparent approach where all of the stakeholders can see what's in the box, and we can make tweaks and adjustments to it for the next season and for the next game even. We know what we're doing, we know the inputs, we see the outputs, and so we can adjust accordingly. So what is sports science? Sports science is leveraging all of what we know in the scientific processes, biology, physiology, mechanics, anatomy, nutrition, strength and conditioning science, leveraging that to drive sport performance. Ultimately, it's different than exercise science, but the two are complementary to each other, but they are still distinctly separate fields. Thanks for checking out this live lecture style video. I'll also record some of our lab practicals from this course, so you can take a look at some of the equipment that we use in our program, that we use both in our monitoring program and to teach our students, whether that is the force platforms or the NORD board or the timing gates. Let me know if you would like more detailed videos walking through the setup of that equipment, how we use it specifically in our research and in our athlete monitoring. Be happy to make specific videos for each of those, whether it's individual tests or for that equipment. Thanks for checking out this live lecture style video. There will be more to come. So stay tuned and I'll see you guys in the next video. Dr. Goodin here, back with another lecture.